Hello, today we're going to talk about factoring, and the method we're going to focus on today is factoring with perfect square trinomials. Perfect square trinomials. And the first criteria for factoring a perfect square trinomial is that it has to have three terms. It has to have three terms to be a trinomial, so we're looking for two add or subtract signs to break that up into each of the three terms. And if we review multiplying a binomial times a binomial doing FOIL, if we look at a plus b times a plus b, I multiply first times first. A times a is a squared. Outside, a times b is ab. Inside, b times a alphabetically is ab. And last times last is b squared. And if we combine like terms, we'd have a squared plus 2ab plus b squared. So today's pattern we're looking for really starts with the solution of a squared plus 2ab plus b squared, and we change it into a plus b times a plus b. So for a perfect square trinomial, we'll start with an example. We have x squared plus 10x plus 25. First, do we have a trinomial? Yes, we have a trinomial. And the first term must be a perfect square. All right, x squared is a perfect square. So far, so good. The last term must be a perfect square. Well, 25 is 5 times 5. That is a perfect square. And then it sounds a little bit more complicated. This middle term must be twice the product of the square root coefficient of the first and last term. Sounds really complicated, but let's look at what that really means. So that means the square of the first and last term. So the square of 1 is 1. The square of 25 is 5. If I multiply 1 times 5 together and double it, 1 times 5 is 5, doubled is 10, do I get the middle term? So that's what I showed here with this 2 times 5 times 1. The square of the 25 is 5, the square of the 1 is 1, and twice that would be multiplying by 2. And does that come out to be the middle term? Yes. And we're not really worried about the sign, we're worried about the number part, the coefficient part, not necessarily the sign, because we can adjust for the sign differently. So this meets our criteria, perfect square subtraction. We check that middle term. And if that is true, then the factored form is going to be the square of the first, the square of the last, and the sign of the middle multiplied twice. So let's look at that. So we have, if you have a perfect square trinomial, it's easy to factor. We're going to take the square of the first term. Square root of x squared is just x. We're going to take the square root of the last term. 25, that's 5. And then we're going to use the sign of the middle term, put them in parentheses, and square the result. So that's going to be x plus 5, quantity squared. The square of the first term, which was x, the square of the last term that was 5, and that sign of the middle term. That's why we weren't so worried about what sign that middle term came out to be, because we're going to take care of that sign part by using the sign of the middle term, and then quantity squared. And I could write that out as x plus 5 times x plus 5, have them both as two binomials, or I can just write it as x plus 5 quantity squared. All right, let's look at a new example. M squared plus 8m plus 16. We have a trinomial. The first term must be a perfect square, and m squared is m times m. The last term must be a perfect square. 16 is 4 times 4. And then we have to check that middle term. Checking that middle term would be twice the product of the square root coefficient of the first and last term. All right, square root of 1 is 1. Square root of 16 is 4. 1 times 4 is 4. Doubled is 8. So the middle term works out fine. So we have a perfect square trinomial. So since we've determined it's a perfect square trinomial, easy to factor. Square the first, which is m. Square the last, which is 4. And then the sign of the middle, in parentheses, squared. So I get m plus 4 quantity squared. So it has to meet all those criteria. If it doesn't, then you're looking for a different method. You're looking for to pull out a GCF, or you're looking for traditional where it multiplies to be the last term but adds up to the middle term. You're looking for a different method. But if it meets all these criteria, then quick and easy to factor with perfect square trinomial if you can recognize the pattern quickly. All right, let's say we have p squared minus 18p plus 81. Is the first term a perfect square? Yes, p times p. Is the last term a perfect square? 81? Well, 81 is 9 times 9, so that is a perfect square. Then I have to check that middle term. Is the middle term twice the product of the coefficient of the first and last term? Twice the product of the square root of the coefficient. So 81, the square root is 9, 1 is 1. 1 times 9 is 9, doubled is 18. So yes, we meet our criteria for a perfect square trinomial. Square of the first is p, square of the last is 9, and sine from the middle is negative. So I'm going to get p minus 9 squared. Notice how these signs match. Signs must match. All right, let's try this one. We got some big numbers to deal with. We got 121 p squared plus 110 p plus 100. We have a trinomial. The first term is a perfect square. 11 times 11, or 11p times 11p is 121 p squared. The last term is 100. 10 times 10 is 100. Then we need to check that middle term. Well, the square root of 121 is 11. The square root of 100 is 10. 11 times 10 is 110, and doubled is 220. Does 220 match that middle term? No, it does not. It does not, it does not, it does not. So that is not a perfect square trinomial. So cannot factor this with PST or perfect square trinomial. So our methods for factoring for binomials, we're looking for greatest common factor or difference of squares. Those are the ones with two terms. If I have three terms, I'm always looking for that GCF first. I can look for traditional factoring, goes by a few other names. You can also, that's where you're looking for two numbers that multiply to be the last term and add up to the middle term. And now our new method of perfect square trinomials. All right, so I want you guys to try these 5, determine if it's a perfect square trinomial. If it is, factor it. If it's not, you can write no. Pause the video here and come on back. All right, welcome back. This first trinomial, perfect square. The square root of 1 is 1, square root of 16 is 4, doubled is 8. So it is a perfect square trinomial. Square the first, square the last, sine of the middle, squared. How about this one? Trinomial. Square root of 49p squared is 7p. Square root of 4 is 2. 7 times 2 is 14. Doubled is 28. So it is a perfect square trinomial. So I get 7p minus 2 squared. How about this one? Trinomial, yes. Perfect square, yes. Perfect square, yes. Let's check that middle term. Square root of 49 is 7. Square root of 36 is 6. 7 times 6 is 42. Doubled is 84. That does not match. No, no, no. Cannot match on that middle term, so not a perfect square trinomial, will not factor. How about this one? Perfect square, yes. Perfect square, yes. 2 times 1 is 2, doubled is 4, so the middle term works. So square the first, square the last, sine for the middle term, quantity squared. We have a perfect square trinomial to factor. Last one. Square root of 225 is 15 times 15 is 225. Don't run into that very often. 15 times 1 is 15. Doubled is 30. Well, this is not 30. That is 50. So that middle term does not work. So that is not a perfect square trinomial. So I hope that gets you guys all going with factoring using perfect square trinomials. And remember that list of things. When you have a binomial, you're looking for GCF. You're looking for difference of squares. When you have a trinomial, you're looking for GCF, you're looking for some method of traditional factoring, and now you're looking for that perfect square trinomial. Have a great day. OUT spells out.